Hello, AP Statistics students. This is your AP Stat tutor, David Cho. Throughout this video, we'll learn about the shape of distribution and the concept of percentile. Before we move on, let's do a quick quiz. What is the type of distribution that this guy used? Yay, you got it correct. This is called histogram, where you can describe the frequency on the y-axis and the explanatory variable on the x-axis. So today we'll go over some shapes of distribution. So let's take a look at the first one. Before I explain, can you guess what are some characteristics of the first graph? Yeah, you can see like most of the data are in the center, and as you go farther away from the center, the frequency of the data gets lower. And sometimes we call this a bell shape, since it looks like a bell. And in statistics, these kind of distributions are called normal distribution. Next one we have here. It says the frequency is the number of days and the explanatory variable is daily high temperature. And as you can see, there's a two peak at the a lower side and the upper side. And as you go to the middle, it kind of shrinks like U-shape. And this kind of distribution where we have two peaks at different value is called bimodal distribution. Next, we have state representative, number of states for frequency, number of representative as explanatory variable. And you can see that most of the data are within 0 to 10 range. And as the number of representative goes up, the frequency goes down. This kind of distribution is called skewed right distribution. So when you have lots of data on left side, while there are only few data on the right side, we call this skewed right. Next one, I think you guys can guess it without explaining it because it's really similar to the left one. It's just horizontal flipped of the left version. So pause the video and try to come up with your own answer before I explain. Alright, so this time we have most of the data on the right side and there's only few data on the left side. And this is called skewed left. Alright, we have the final one, which is results from die roll. So we have number of rolls for frequency, or the response variable, and result, either 1, 2, 3, 4, 5, or 6, as explanatory variable. But unlike other graphs, I'll show you other graphs, it doesn't have like significant change or trend. It's just that all the numbers have very similar frequency. And these type of data are called uniform data. So let's do a quick review here. When most of the data are in the center and the frequency of the data gets less as it gets farther away from the center, we call this either bell shape or normal distribution. When we have, it doesn't really have to be U-shape. The point of bimodal distribution is that we have two different peaks with like not one being too extreme. It's just that we need two peaks in order to make a bimodal distribution. And when we have lots of data on the lower side, but only few data on the right side, we call this a skewed right distribution. Or in a sentence, we called the distribution is skewed to the right. And on the other hand, when we have lots of data on the right side and only few data on the left side, we call this skewed left graph, or the data is skewed to the left. And lastly, when all the data have similar distribution, we call this a uniform distribution. Okay, now we're gonna learn something called percentile. Well, if you have taken some tests like SAT, TOEFL, or something, you might see something called percentile. Like your score is on 99th percentile, your score is on 95th percentile, or whatever. So the actual definition of the percentile is score at or below which a given percentage falls. Or, in other words, percentage of the data that are smaller than or equal to the given value. So, for example, um, if you got 95 on a math test and your score is 90 percentile of the score, that means that 90% of the scores are below or equal to 95. So let's say you have 10 students in total, including you, and uh, your score of 95 is actually on 90th percentile. That means that including your score 95, 9 out of 10 scores are actually below or equal to 95. Well, which means that uh, there's only one student who received higher than 95, and you're like second place out of 10 people. And here's the thing called box plot. Box plot is also one of the data visualization that explains the one-way variable. Wait, actually two-way variable, because it also explains the frequency of certain data. So here we have a number of goblins, and we have some uh, important elements that uh, that forms the box plot. So here on the left we have a small dot here called minima. This is the smallest value in the data, which means that the 40 is the smallest number of goblins that are in the sample or in the group. And here we have 41 as our 25th percentile, meaning that 25% of the data or the sample has actually less than or equal to 41 goblins. And here's a thing called median, or often we call this a 50th percentile. This is uh, this means that half of the data are less than or equal to median. So, which means that 50% of the data is less than or 50% of the sample has less than or equal to 42 goblins in, let's say, in their village. And 75th percentile works similar, meaning that 75% of the sample has less than or equal to 45 number of goblins in their like sample. And maximum is that uh, the maximum number of goblin in a single village is 50. Okay, and there's one important thing called IQR, which is interquartile range. I will explain that in the next video. Now let's try out some Khan Academy problems. So here's the box plot that summarizes the number of goblins in each village. Which of these best describe the shape of the distribution? So here you can see that the median is more close to 25th percentile rather than 75th percentile and maximum. So we can interpret that we can make an assumption that here we have 50% of the data, and here we also have 50% of the data. But if we have 50% of the data on both left and right side, which one would be more crowded, more dense, or which one contains more value within the smaller range? It might be the left side, because we have to distribute those 50% of the data on either 40, 41, or 42. However, on the right side, we can distribute those 50% of the data from 42 to 50. So which means that here we're gonna have less, how should I say, less dense data data on the right side. Oh, I'm sorry. And on the left side, we're gonna have a more dense data. So this one cannot be symmetric because one side have more compact data than other. So it's non-symmetric. Let's see a step-by-step solution. Oh yeah. And this one. As you can see, the left side, the data are focused on the left side and there are only few data on the right side. So this is skewed to the right. Let's move on. Greg recorded the shell time for the... Okay, this one is also skewed to the right because we have smaller data on the right side and more data on the left side. Here's a box plot that summarizes the price of each order at Winston's which of the distribution. So, like the first question, the median is more close to mean and 25th percentile rather than 50 percentile and maximum. So this cannot be symmetric. Oh, yeah, not symmetric. I'm sorry. Yay. And let's try this one, describing distribution. Untracked. Oh, wait. Oh, actually, let's try this describing distribution later because we have to go over some other concepts in order to solve these problems. Okay, then that's it for today. If you have any question, please visit Peer Tutoring Club website and find out some time that the tutoring section is available. Then you can get some help from our tutors in Peer Tutoring Club. Thank you for listening to my lecture, and I was David Cho, I was AP Stat Tutor.